Hello everyone, very good evening and welcome to Prep Funda. How are you guys? First of all, inform me that sound quality, picture quality, everything is fine. Yes, please. If everything is fine, then we are going to start this session, that is what network circuit theory through questions. It is a part of series Network Navigator, your guide to network concepts, guys. Okay. So already I have discussed number of topics. Now today I am going to discuss what first order transient with RC circuit. First order transient with RC circuit. And as you know, this is a very important topic for all competitive exams, especially for GATE and what engineering services exam. तो अब उस अम्ब्रेला के तहत सभी कुछ आ जाता है, चाहे वो HPCL हो, चाहे इसरो हो, चाहे और कोई अदर कॉम्पिटिटिव एग्जाम्स है. तो देखिए जरा साउंड क्वालिटी, पिक्चर क्वालिटी, एवरीथिंग इज फाइन गाइज. यस प्लीज. नाउ ज्वाइन द सेशन. 1 minute, give me 1 minute. I think okay. Okay, everything is fine now. Now guys, in a previous session we have discussed the first order transient with RL circuit. Inductor does not allow sudden change of current. Okay, and we have learned about the steady state condition, initial condition for inductor. Our inductor is important for what? Inductor is important for electrical students, right? But we are getting question for electronics, for electrical students, for instrumentation branch, right? Now that we are going to discuss what RC circuit. So RC circuit is a very important for what analog. If you want to understand the concept of analog, for example, integrator, low pass filter, high pass filter, okay, or what just to understand the concept of what monostable multivibrator or stable multivibrator filter, concept of RC circuit is required. So right, Tharan, thank you for your feedback. Now first of all, like the session or subscribe the channel. Why? Because simply I am going to take what number of important session on this. This is a new channel, तो आपको नोटिफिकेशन मिलता रहे और आपको इंफॉर्मेशन आते रहे, बिकॉज दीज ऑल आर व्हाट फ्री क्लासेस, तो यू कैन ज्वाइन हियर. ओके, देन गाइज अब हम लोग डिस्कस करेंगे आरसी सर्किट. इन दिस सेशन आई एम गोइंग टू डिस्कस व्हाट इज द आरसी सर्किट, source free RC circuit and RC circuit with source and with important numericals. I am going to discuss around 5 to 6 important numericals on this. Okay, so first of all, that is my introduction. 24 years of teaching experience. I have qualified and selected for engineering services exam multiple times. These are my ranks: AIR 16 in ESE 2005, AIR 21 in ESE 2008, and I have trained more than 1 lakh students for these competitive exams through offline classes and online classes. That is my Telegram channel, Electronics by Sanjay Rathi. You can join for PDF of this session and for notification of all other classes. We have around 7 months, and within 7 months I am going to take number of sessions on different topics, different subjects. Okay, and you can also suggest me on my Telegram channel, sir, we want session on this particular topic. So you can join. And guys, I am going to take very important session for you today evening at 9:30 p.m. Journey to GATE, right? It may be 2025, it may be 2026, or it may be 2027, right? Or any competitive exams, how to build concepts. That is a very important. Why? Because we are just saying that no need to mug up. Don't try to mug up, right? In exam, we have to solve the numericals, and it is possible when you have the command word or concepts. So we are going to start a very important series, that is what daily ka funda plus daily ka dose. Okay, so daily what we are going to do, that we are going to discuss today at 9:30. Please everyone note the time and subscribe the channel so that you are not going to miss this session. तो आप लोग सभी आइए 9:30 PM पर. Within 30 minutes we are going to discuss तो daily का funda and what is the daily का dose and how we can effectively use this series. Just it is a way to what? Success, right? So this is a very important series and it is a full proof series. तो जब आप इसमें कमांड करेंगे फंडे पर, तो आप कैसे न्यूमेरिकल सॉल्व करेंगे, ईच एंड एवरीथिंग वी आर गोइंग टू डिस्कस. तो सब्सक्राइब द चैनल so that you can join. अब आते, that is the first question. So everyone please note the question and try to solve. Before solving this question, just I will give you the brief idea about the RC circuit. Then we are going to solve this question. The switch in the circuit in figure has been closed for a long time. This switch is closed for a long time and it is opened at t equal to 0. Find Vt for t greater than or equal to 0. Calculate the initial energy stored in the capacitor. So you have just simply give me the answer. What is the energy stored in the capacitor? Okay. And please share the link so that your friends will join the session. Okay. Now, so first of all, watch this. Just I am going to discuss something. First of all, what is the RC circuit? Remember, there are two types of RC circuit. One is with source. This is the RC circuit with source. Just I am taking the DC transient. This is the DC voltage, like this is the Vs. And exactly at t equal to 0, the switch will close. And this is the R and this is the C. Normally asked, what is the voltage across the C? Right? What is the voltage across the C? Okay. First important thing, remember, capacitor does not allow sudden change of voltage. Capacitor does not allow sudden change of voltage. Right? Because why? Because I is equal to what? dq by dt. And what is the q? Cv. When we are differentiating, C is constant, C dV by dt. That is the formula I through the capacitor. If it will allow the sudden change of current, what is the meaning of the sudden change? That dV by dt will become infinite. Yes. If it is infinity, then what about the current? Current will become infinite. Sudden change means abrupt change. In 0 time, there is a change in the voltage. The rate of change will become infinite and then current will become infinite, and that's why it will not allow the sudden change of voltage. Okay. Then in this RC circuit, we have to use this equation. Vc is equal to V final, V initial e raised to power minus t by tau. Now, how we can use this effectively? You can solve any type of questions. V final means exactly at t equal to infinity, what is the voltage across the capacitor? So always remember, for DC, if suppose we are going to close the switch, then exactly at infinite, this capacitor will act as open circuit for DC. Let that switch is closed, and exactly at infinite, the capacitor is fully charged and it will act as open circuit. Therefore, what is the final voltage across the inductor? It will become Vs. This one, suppose it is 10 volt, then capacitor will charge up to 10 volts, capacitor will charge up to 20 volt and so on. It depends upon the Vs. Now, exactly at t equal to 0, what is the value? This is called initial condition. Capacitor does not allow sudden change of voltage. If suppose the initial voltage is 0, then it will, just after switching, it will remain 0. Just before switching, if it is unenergized, then after switching again it will remain unenergized. And suppose before switching the voltage across the capacitor is 5 volt or any voltage, then it will remain same. So what is the Vc0? Negative. If it is any value V0, like V0 is the 5 volt, then it will remain what? 5 volt after switching. Why? Because capacitor does not allow sudden change of voltage. Now finally, so we have, first of all, at infinity it will act as open circuit. Under steady state it will act as open circuit. Initially it does not allow sudden change of voltage. Two things. Now if you have the initial value, you have the final value, you can use this formula. And what is the tau? Tau is the time constant of the circuit. For example, what is the time constant of this circuit? RC. RC. Finished. You have to use, suppose the initial value is 0, then what will be the formula? Suppose the initial value is 0, then what will be the equation? So just I am going to solve for you two cases. First case, if the initial value is 0 and final value is Vs, then this will become, final value is Vs minus 0 e raised to power minus t by RC. And finally you will get Vc is equal to Vs 1 minus e raised to power minus t by RC. Direct equation. Now, if you are getting this equation when initial value is 0. Now, can you plot this? Yes, we can plot. It is an exponentially increasing function. It is an exponentially increasing function. Final value is Vs. Capacitor will charge like this, exponentially it will charge. Exactly at 0, what is the voltage across the voltage? 0, because capacitor does not allow sudden change of voltage. Before switching it was 0, just after switching it was 0. In one time constant, it will charge up to 0.638 times of Vs from this equation. 1 minus e raised to power minus t by Rc. One time constant means Rc, so Vc will become Vs. 1 minus e raised to power minus 1, you can find it will be 0.638 of Vs. For 4 time constant, it will become 1 minus e raised to power minus 4, and it is nearly equal to 0.98 times of Vs, 98%. When we are saying that if it is charged up to 98% or 99% in 5 time constant, then transient is over and steady state. For example, up to this point, if it is charged up to 98%, then we can say from this point to this point, it is transient. And finally, after that, circuit reached to what? Steady state. Steady state. That is called 4 tau. After 4 time constant, circuit will reach to what? Steady state. Or after 5 time constant, it will charge up to what? 99%. So some students are, in some books it is taken as e raised to power minus 5, means after 5 time constant. So you can also use 5 time constant, it will become 1 minus e raised to power minus 5. It is nearly equal to 0.9916 Vs. So this is the graph exponentially charging equation, guys. Exponentially charging equation. So all are ready to solve some questions. With questions, now you will get what is the effective use of this formula. So I have given you the basic idea how to find the final value, how to find the initial value. So just revision. Or any diagram, always remember capacitor does not allow sudden change of voltage. So just before switching find the voltage, and capacitor just after switching will not allow the sudden change. After that, with the new condition, for example, before switching what is the voltage across this? 0. Then after switching it will remain 0. If before switching it is V0, after switching again it will remain V0. Now after switch is closed, find the final value. Finally, for DC, capacitor act as open circuit. This is the open circuit, and that is the diagram valid for this circuit at t equal to infinite. What is the voltage across the capacitor? Vs. So if you have the final value, initial value and equation, time constant, you can directly use. Okay, I am going to solve first question for you. What is the use of this equation? That is a very, very important one. Everyone please note this equation. And almost all the question will be solved by using this equation. Okay, in RC circuit, first order RC circuit. Then now watch this. What is the question? What is asked in question? Now watch this. The switch in the circuit in figure has been closed for long time. So initially it is closed. So when it is returned, it is closed for long time and it is opened at t equal to 0. So for t less than 0, switch is closed. For long time means we can say from minus infinity. For long time means, for example, it is t equal to 0. Long time means for t less than 0, you can also say from minus infinity, means it will take sufficient time so that the capacitor will charge. So that the capacitor will fully charge, means exactly at 0 negative. Means it is coming from the minus infinite to up to what? T0 negative, just before switching. This is called just before switching. So capacitor is fully charged because it is DC voltage. Therefore, exactly at 0 negative, again the circuit is in steady state with the switch closed. Therefore, capacitor act as open circuit. When capacitor act as open circuit, everyone tell me what is the voltage across the capacitor before switching. This is the open circuit. This is the 20 volt. And that is the position exactly at t equal to 0 negative. And after for long time this switch was closed. Now so this is 3 ohm, this is 9 ohm, this is 1 ohm, and now this capacitor will act as open circuit for 0 negative. Circuit is under steady state with switch closed. So according to voltage division rule, V0 negative is equal to 9 upon 3 plus 9 into what? 20 volt. 9 upon 3 plus 9 into what? 20 volt. So you will get, this is the 9, this is what? 9 plus 3, 12, and it will become 9 divided by 12 into 20, that is 3, this is 4, 15 volt. So VC0 negative is equal to VC0 positive is equal to what? 15 volt. So what is the initial voltage across the capacitor? 15 volt. And capacitor does not allow sudden change of voltage. So 15 volt. And second question, what is asked? What is the initial energy stored? Now you can find the initial energy because initial voltage is 15 volt. So what is the energy? Initial energy is given by W0 half of CV square. So half into what is the C here? Value of the C is 20 millifarad. 20 into 10 raised to power minus 3 into V square, 15 square. So it will become 10, and that is 15 square means what? 225, 0 into 10 raised to power minus 3 millijoule. Sorry, joule. So what is in millijoule? Or 2.25, right, joule. 2.25 joule, and that is done. Please check my calculation. So this much energy is stored in the capacitor. Now we have, so first of all, switch is closed. Initially the switch is closed and we are going to open. So before opening the switch, circuit reached to what? Steady state, and that's why this capacitor has some initial voltage. What is the initial voltage? 15 volt. It has some initial energy, 2.25 joule. Now the switch is opened. Switch is open means what? Capacitor does not allow sudden change of voltage. So voltage across the capacitor will remain 15 volt. If this is the diagram at t equal to 0 plus, this will act as open circuit. You can remove this diagram. What is the voltage across the capacitor? 15 volt remain. Now what will happen? Because this is now the switch is open, capacitor will discharge through this. Capacitor will discharge through this, and there is no other active source. Now the capacitor behaves like what? Active source. Therefore, capacitor will discharge through this 9 plus 1, 10 ohm. So what is the time constant for this circuit? RC. What is the R? 9 plus 1, 10 into C, 20 into 10 raised to power minus 3. It is become 200, or 200 minus 3 means it will become 0.2 second. Because I have converted into farad, this is the ohm, so that is the, you are getting the 0.2 second, 1 by RC, right? This is the time constant. Now there is no other battery. So what will happen? The capacitor will fully discharge if we are giving sufficient time. So what is the final voltage across the capacitor? 0. How we can say? Because there is no active source in this portion, because this is cut out. So what is the final voltage across the capacitor? 0. What is the initial voltage across the capacitor? 15 volt. We have the final voltage, we have the initial voltage, we have the time constant. So what is the use of this equation? Very, very simple use. Put all the values. VCT is equal to V final minus V final minus V initial e raised to power minus t by tau. What is the final value? 0. What is the final value? 0. What is the initial value? 15 e raised to power minus t by 0.2. So it will become 15 e raised to power minus 5t, and that is equation is valid for t greater than 0. That equation is valid for t greater than 0. So that is the case guys, t greater than 0. तो इस तरीके से you can find the answer. You can find the answer. So in exam, don't worry about the question. You have to find the initial condition. You have to find the, always remember to find the initial condition. First of all, draw the circuit exactly at 0 negative. 0 negative means it is coming from minus infinite to 0 negative, and 0 negative is what? Circuit is under steady state. And therefore, for DC, capacitor act as open circuit. Use the voltage division rule, find the voltage across the capacitor, and this is the 15 volt. Now 0 positive act like what? Initial condition. So what is the initial voltage? Because capacitor does not allow sudden change of voltage, that's why it will remain 15. So this is the 0 positive. Now when the switch is open, exactly at t equal to infinite, what will happen? The capacitor will fully discharge because there is no active source. Therefore, final voltage is 0. To use this concept, you have to use only one equation. You will get this answer. Suppose it is given, plot it. प्लॉट करना. तो how we can plot? कैसे प्लॉट करोगे भाई? Plot VC at all time. Or remember, this is the VC. This is 0. Before 0, what is the value? 15 volt. So you can plot like this. This is the 15 volt, almost constant. It does not allow sudden change of voltage. After 0, it will follow this curve. 15 e raised to power minus 5t, exponentially decreasing function. Or exactly at infinity, it will become 0. Exactly at infinity, it will become 0. Right, and that is the case. Okay, so exponentially decreasing function. So that is the case. So ये है plot. And remember, there is no discontinuity. Exactly at this point, for t less than 0, for t greater than 0, this is the value will remain same, and there is no discontinuity because capacitor does not allow sudden change of voltage. This is time. Voltage across the capacitor with respect to time. This is the equation, and that is the curve for t less than 0, and that is for t greater than 0. This is the point 0 negative, this is the point 0 positive. 15, 15. Just before switching, just after switching. So with this one question, you will get idea, and that is the question from standard textbook, Alexander and Sadiku. Now, I think now you got the idea how to use this equation. Now, guys, before solving the next one, just I want to give you one information that last week I have taken complete series on network, and this week again I will arrange according to your response. Do you want? And please suggest me, because I want to take session on what? Second order transient, then what? Power factor, steady state analysis of the sinusoidal signal, right? And how to find the complex power and so on. So if you want, then please write in comments or on my Telegram channel. So already I have taken general session how to cover network. Please watch that. You will get the idea. And I have given one strategy 50 plus 30 plus 10 plus 5. Please go through that. And then KCL, KVL, Thevenin's Norton's theorem dependent, two-port network, and first order transient, RL circuit, RC circuit, and so on. To go through all this, already I have shared the playlist of this. And if you find any difficulty, if you want any detailed explanation, then suggest me, I will arrange session for you. Okay. So just this is the concept through numericals. Now, what is the answer for this one? Very basic question just for HPCL. बताओ जरा आंसर क्या होगा? A capacitor in an RC circuit with R is equal to 25 ohm and C is equal to 50 microfarad is being charged with initial 0 voltage. What is the time taken for the capacitor voltage to reach 40% of its steady state value? Right, a capacitor in RC circuit with 25 CMI being charged with initial 0 voltage. What is the time taken for the capacitor voltage to reach 40% of its steady state value? 40% of its steady state value. Can we find this? Being charged with initial 0 voltage. तो देखिए, फर्स्ट ऑफ ऑल रीड द क्वेश्चन केयरफुली. बीइंग चार्ज means like this is the question, this is the C. What is the initial voltage across the capacitor? 0. And what is the final voltage? Finally it will act as open circuit, like this is the Vs is the battery. Exactly at t equal to 0 the switch is closed. Already I have given what is the equation, Vs 1 minus e raised to power minus t by RC. Now what is question asked? The time at which it will reach to what 40% of its steady state value. So what is the steady state value? Steady state means at t equal to infinite, what is the value? That is the capacitor act as open circuit, that's why Vs is the steady state value. So what is the 40%? So let at t equal to t1 Vc reach to 40% of its final value, that is the 0.4 Vs. Can you put in this equation? Yes, we can put. That it will become Vc is equal to Vs 1 minus e raised to power t by RC. It will become 40% of Vs, means 0.4 Vs 1 minus e raised to power minus t1 at the time t1 RC. This Vs cancel because no need to, that is the final value. So applied voltage is Vs. Then it will become e raised to power minus t1 by RC is equal to 1 minus 0.4, that is what 0.6, and then you can take what log of that, or you can put here e raised to power t1 by RC, you can change 1 by that, so it will become 1 by 0.6, right, that is 10 by 6 or 5 by 3. Take the log, so what is the t1 is equal to RC log of 5 by 3. RC log of 5 by 3. So what is the log of 5 by 3? Point 510. 0.510 RC. What is the value of R and C in the question? 25 ohm and 50 microfarad. So T1 will become 0.510, 25 ohm, 50 microfarad, 50. So what is the given in the answer is given in the what? Millisecond. So you can 50 into 10 raised to power minus 3. This is the millisecond. Micro is converted into milli. To multiply it. So it will become 25 into 50 into 0.510 divided by 1000. 0.6375 I am getting. 0.6375. What is your answer? So I think A is the answer for this question. Right. So please check my calculation. So what is the question? Write down this. Always remember in one time constant, it will charge up to what? 63.8%. 60 in one time constant, mean in 1 RC it will charge up to 63.8, means answer will be less than that because we have to charge up to 40% only. So what is the value? This is the RC and this is the only the 50% of the RC. Definitely it will be less than RC. So answer is what? This one. Check my calculation and so on. So this is the results, guys. To put the value 40 of that 0.4 Vs and take the log and you can solve like this. That is the answer. Okay, then next one, next question. Very easy one. So in a HPCL exam or in ISRO exam, they will ask this type of questions. Find the time constant of the RC circuit shown in below. What is the time constant here? कुछ comments box में भी बताइए आप लोग. What is the time constant of this circuit? What is the time constant of this circuit? Find the time constant of the RC circuit shown below. 90 milliseconds, 60 milliseconds, 30 milliseconds, 3 milliseconds. Suppose you want to find the time constant. So what is the rule here? C is given but R is not clear, then guys, time constant is RTH into C. What is the RTH? What is the Thevenin's resistance seen by a terminal AB? So remove the C and find the Thevenin's resistance. So already in my session on Thevenin's, I have given how to find the Thevenin's resistance. So if you want to find the Thevenin's resistance across A and B, you have to make it what? 30 volt 0. When we are making the 30 volt 0, 20 and 80 are in parallel and then 44 in series. So you can solve like this. First of all, make it what? 0. Make it 0 means voltage source is short circuited. Second thing, make it open circuit capacitor, because we have to find the Thevenin's here. A and B. Now what is the resistance seen here? 20 and 80 are in parallel plus 44. That is the RTH. So what is the 20-80 parallel? 20 into 80 divided by 20 plus 80 plus 44. So it will become 1600 divided by 100 means 16, or 16 plus 44 is just 60 ohm. This is the value of RTH. This is the value of RTH. Then what is the C? C is 0.5 millifarad. What is the time constant? RTH into C, 60 ohm into 0.5 millifarad. It will become 30 millisecond. It is in second. You can convert it into what? Millisecond. So it is a millisecond. 30 millisecond. C is the answer. So in some competitive exams, they will ask very simple question like this. Find the time constant. So in whether it is a dependent sources or independent sources, if the only one capacitor is connected and you have to find the Thevenin's, you have to find the time constant. First of all, remove the C and find the RTH across terminal A and B, and then you can find the time constant. That is a very simple question. 30 millisecond. Now this is the one type of questions. So guys, and we have application of what? RC circuit in analog. So you will get the command over this. Then guys, in analog, in filter circuit, for example, rectifier and filters, capacitor filter, inductor filter, or choke filter, right? Or what? LC filter, where we are using inductor and capacitor, we are using concept of transient, only first order transient. So if you want to watch, then this is, I am taking the comprehensive course, analog electronics, ideal and practical diodes with numericals. Already paid classes is going on, at very nominal fees. Morning 6 to 8, so you can join. For more detail, you can pin me, you can message me on my Telegram channel, or my WhatsApp number is given in description, right? Or you can directly join that, right? I will share the link with you, so you can directly join that course, go through the fee structure and so on. It is analog. And then, so I think now you are ready to solve some special questions. That was the question in GATE exam. That was the question in GATE exam. Again, that is on first order circuit. What is the answer for this one? So it is a previous year question from the GATE exam. Now, what is the diagram is not given, but you can. A resistor and a capacitor are connected in a series with a 10 volt DC supply through a switch. So you can draw the circuit. Resistor and a capacitor connected to a 10 volt DC supply through a switch. And this is the switch. 10 volt DC supply. Now the first statement is over. The switch is closed at t equal to 0. Switch is closed at t equal to 0. Very important one is go through the language of this question. If the switch is closed at t equal to 0, the capacitor voltage is found to cross capacitor voltage is found to cross 0 volt at t equal to 0.4 tau. Means, what is the tau? Where the tau is the circuit time constant. What is the time constant of this circuit? RC. And what is written here, at a time t equal to 0.4 tau, it will cross the 0. Guys, according to our concept, if the 10 volt battery is given, if the initial voltage across this capacitor is 0, then what will happen? Watch, first of all, read question carefully. Then what will happen? The capacitor will charge like this. Already I have given. Capacitor will charge like this. Final value is 10 volt. Initial value is 0 volt, and that's why the capacitor will charge like this. Okay, this is the 10 volt. If suppose it has positive voltage, it has initial positive voltage, then capacitor will charge like this. Suppose it has the positive value 4 volt, then capacitor will charge towards the 10 volt. Or initially let it is a 4 volt. Initially it is a 4 volt, then it will start charging from 4 volt and then exponentially charge towards what? 10 volt. If the initial voltage is positive, then this is the, if there is an initial voltage, then that will be the case. If there is an initial voltage is 0, then that will be the case. But in both the cases, tell me, it will cross 0 volt? No, not possible. It will charge toward 10, it will not cross the 0 volt. Initially it has the positive voltage, it will finally charge up to 10 volt because 10 volt battery is connected. Again it will not cross the 0 volt. So in which case it will cross the 0 volt? If the initial voltage across the capacitor is negative. If the initial voltage across the capacitor is negative, means for example this is the 10 volt, switch is closed, this is the RC. Now initial voltage across the capacitor is negative, means this is the polarity, it has any initial voltage. Now what will happen? The capacitor will charge like this. So first of all, that initial voltage will become 0. And then it will charge towards what? 10 volt. Then it will charge towards what? 10 volt. Then it will cross the 0. So according to the given information, capacitor has some negative voltage. Capacitor has some negative voltage and it will start charging from that negative voltage, like it may be V0. Okay, and so this is the initial voltage, does not allow sudden change of voltage. Now capacitor start charging towards what? 10 volt. Then definitely at particular time it will cross what? 0 volt. From negative initial voltage cross the 0 and finally it will charge up to 10 volt. So at which time it will cross? 0.4 tau. So you can write here 0.4 tau. Very simple thing, where first order circuit you have to draw the diagram only. So at 0.4 tau it will cross the 0 volt. Now the absolute, what is the question here? The absolute value of the percentage change required in initial capacitor voltage if the 0 crossing has to happen at what? T equal to 0.2 tau. Suppose the initial voltage is any value minus 4 volt, it will cross 0.4 tau. Now what should be the change in the initial voltage so that it will cross the 0 at 0.2 tau? Half of that. Guys, you have to reduce the magnitude of the negative voltage, the magnitude of the initial voltage. That's why, if suppose the initial voltage is this one, let this is the V-0. If it will start charging, then definitely it will charge like this. And then it will cross the 0 line at what? 0.2 tau. So what is the question here? According to the language, what is the percentage change required in the initial voltage if the 0 crossing has to happen at what? 0.2 tau. So from the diagram, we have to reduce the magnitude of that. For example, it is minus 4. Just I am giving you the, it is not exactly minus 4. If it is minus 4, we have to make it what? Minus 2. Why? Because we want to reduce the time. We want to reduce the 0 crossing time. So definitely we have to reduce the magnitude of the initial voltage. So what is the absolute percentage change? So absolute percentage change will become percentage change according to the question V0, because the magnitude of that, because it is a higher magnitude, minus new value of the initial magnitude upon what is, we have to find the percentage of that initial value. In first case, this is in second case, this is in first case, into 100. Means we have to find these formula. Now, what is the initial value? If suppose we are able to find this, if we are able to find this, then we can find this. That is a very, very, very easy one, because we have to use only one equation. Which equation? This one. Vc is equal to V final minus V final minus V initial e raised to power minus t by tau. So what is the final value? Finally, it will charge up to a 10 volt. Therefore, at t equal to infinite, it will act as open circuit. It will charge up to 10 volt. The final value is 10 volt. Final value is 10 volt. What is the initial value? In first case, it is V0 e raised to power minus t by tau. Now, exactly at t equal to 0.4 tau, first case, I am talking about the first case, it will become 0. VCT will cross the 0. So, exactly at 0.4 tau, this will become 0. That is the equation to put here. 0 is equal to 10 minus V naught e raised to power minus 0.4 tau upon tau. This is cancel out. Now, put here 10 minus V naught is equal to e raised to power minus 0.4 is equal to what? 10. So it will become 10 minus V naught. 10 divided by e raised to power minus 0.4 means it will become 10 into e raised to power 0.4. Get what is the value here? So you will get 0.4 into 10. 14.91. This value is what? 14.91. Check my calculation. Now, what is the V naught? So, V naught will become ten minus 14.91. 918 means it is 92, around 918. Guys, it is negative value. Definitely it is a negative value because it will start from this point. This is the initial value is negative. I just have given the 4, but it is 4.928. Okay, no problem. Now we have the exact value 4.92. So this is the value. Now what is the V dash 0? So that we can use this formula. To just to find a V dash 0, we have to use the same equation. Same, everything same. Everything will remain same. This will remain same, final value is same, but we have to use what is the initial value? V dash 0. V dash 0. Same equation. Exactly at t equal to 0.2 tau. At 2 tau it will become 0. There is a change. Exactly at 0.2 tau, in the second case it will become 0. So VCT will become 0. That's why I put here 0. This is the dash. Exactly here you have to put what? 0.2 tau. Cancel out. Now same calculation. Here you have to put what? Minus 0.2. Same 0.2. Same 0.2. So everywhere 4 is replaced by what? 2. What is the value? Now e raised to power 0.2, it is 1.22 into 10, it will become 12.214. 214. Now what is the V dash 0? This is the dash, second case. So V dash 0 will become 10 minus 12.214. So it will become minus 2.214. Again negative. Again negative. So according to the diagram, everyone tell me everything is fine. Already I have there na. This is the value. It is not 2. It is 2.214. Yes. The magnitude of the second case is less than the magnitude of the first case, but both are negative, and that's why when they are charging, they will cross the zero line. Can we use this formula now? Can we use this formula now? What is the V dash 0? What is the magnitude? 4.92. What is the magnitude in second case? 2.214. 2.214 upon what? 4.92 into 100%. यार कैलकुलेशन तो करो थोड़ा, कितना आ रहा है आंसर, जवाब दीजिए कमेंट्स बॉक्स में. तो 4.92 माइनस 2.214 divided by 4.92 into 100, around 55%. So that was the answer. That was the answer for the GATE exam, right? 55%. So what is the absolute change in that? We have to decrease it by what? 55%. Then it will cross the zero at 0.2 tau in place of 0.4 tau. So what is the beauty of this, guys? When we are making the proper diagram, suppose we are understanding in initial case it will charge in initial, so initial value may be 0, initial value may be positive, initial value may be negative. But if suppose we are saying that it will cross the zero line, then definitely initial value is negative. पक्का होगा ना, नेगेटिव होगा तभी तो जीरो को क्रॉस करेगा. तो आपको ये ध्यान देना है कि जीरो को ये कब क्रॉस कर रहे हैं. इफ इट इज नेगेटिव देन, तो नेगेटिव में भी हमारा मैग्नीट्यूड देखना है कि किसका मैग्नीट्यूड ज्यादा है. तो ये ज्यादा है, ये कम है, इसलिए आपका परसेंटेज है. ये इस लेवल के क्वेश्चन आते हैं भाई गेट एग्जाम में. इस लेवल के क्वेश्चन आते हैं गेट एग्जाम में, तो थोड़ा ध्यान रखिएगा. नाउ तो अब आपका टाइम आ गया भाई असाइनमेंट्स का. प्लीज ट्राई टू सॉल्व दिस क्वेश्चन. Again, this is a very good question. In next class, I will solve this. Guys, 9:30 sharp. Today we are having one session. That is what. So please join that. One minute. देखो भाई, पढ़ना है, एग्जाम निकालना है, तो कुछ कुछ आप लोगों को खुद अपने आप पर कॉन्फिडेंस रख के प्रिपरेशन करनी पड़ेगी. बहुत सारे लोग हैं जो बताएंगे कि हमने एग्जाम निकाला. मैं भी बताता हूं अपना कि मैंने भी एग्जाम निकाला है, देखिए, राइट. बट प्रॉब्लम क्या है पता आपके, कि सबकी स्ट्रैटेजी है अपनी अपनी और सबकी कैपेसिटी भी है अपनी अपनी. यस और नो? यू हैव योर ओन स्ट्रेंथ और ओन व्हाट वीकनेसेस. तो जो स्ट्रैटेजी किसी दूसरे के लिए अच्छी है, कोई जरूरी नहीं आपके लिए वो काम करे. कई बार हम लोग बोलते हैं दिस वाज आवर रैंक. तो रैंक इज ओके, बट व्हाट अबाउट द टीचिंग एक्सपीरियंस, राइट? क्योंकि हर एक स्टूडेंट के लिए ना पढ़ने का तरीका अलग अलग है, स्ट्रैटेजी अलग अलग है. उसको खुद को अपने ऊपर कॉन्फिडेंस रखना पड़ेगा और अपनी एक फुल प्रूफ स्ट्रैटेजी बनानी पड़ेगी कि मुझे कैसे एग्जाम निकालना है. मीन्स सुनो सबकी, करो मन की, लेकिन आप इंफॉर्मेशन लो. अब कोई बोला कि मैंने टॉप किया, मैं आपको टॉप करा दूंगा, नॉट पॉसिबल. कोई पेन ड्राइव है क्या जो आपके दिमाग में लगाएगा तो आपके दिमाग में पूरी चीज आ जाएगी, राइट? तो नहीं हो सकता. तो आपको कंटिन्यूसली उसके साथ लगकर उससे आइडिया लेना पड़ेगा. और अगर उसकी बात समझ नहीं आ रही है तो छोड़ दो उसको. लेकिन ऐसा नहीं कि पहली क्लास में. ट्राई टू अटेंड व्हाट मिनिमम एटलीस्ट व्हाट 10 to 15 क्लासेस. आफ्टर 10 to 15 क्लासेस यू विल गेट आइडिया कि यार ये टीचर अच्छा समझा रहा है, यस और नो, इज इट पॉसिबल फॉर मी. और हाँ, लैंग्वेज में मुझे कमेंट्स बॉक्स में बताइएगा हाउ मेनी स्टूडेंट्स आर इंटरेस्टेड इन हिंदी और इंग्लिश, प्लीज. तो which language is comfortable? If you are saying Hindi or English, then I will arrange session in both the language. तो देखिए, how to build concepts. This is a very very important topic. डेली का फंडा प्लस डेली का डोज. I am going to start डेली का फंडा प्लस डेली का डोज सीरीज and way to what? Success. तो journey to gate, I am going to make it what as smooth as possible for you, right? Exciting journey for you. तो चलिए आइएगा मेरे साथ 9:30 sharp, 9:30 PM. Please join. So subscribe the channel so that you will get the notification. Today 9:30. Please go through all this session so that you will get the command over Thevenin's, KCL, KVL, Norton's theorem, two-port network, ABCD parameter, first order RC circuit, first order RL circuit. And this week I will share the schedule for next topic, like what second order transient, initial condition, power factor, steady state analysis of sinusoidal signal. Okay, तो सब्सक्राइब कर लीजिएगा, टेलीग्राम चैनल जरूर ज्वाइन कर लीजिए, बिकॉज आई एम गोइंग टू अपलोड द PDF ऑन दिस just after the class. I will upload, right? And then finally that is a new channel, guys. Okay, then subscribe the channel, like the session and share the link of this session. Thank you, have a nice day.